Look up at the night sky. What do you see? You see stars, tiny points of light, scattered across an immense darkness. But you are not just seeing light, you are seeing history. The light from the nearest star, Proxima Centauri, took over 4 years to reach your eyes. The light from the Andromeda Galaxy has been traveling for 2.5 million years. When you look at the stars, you are looking into the past. You are a time traveler, whether you realize it or not. This simple act, something we can all do, opens up one of the most profound and perplexing questions in all of science. What is this thing we call time? We wake up, we go to work, we come home, we celebrate birthdays, marking another year of our existence. We remember the past, and we plan for the future. Time is the silent metronome that governs the rhythm of our lives and the entire universe. It feels utterly real, as solid and dependable as the ground beneath our feet. We can measure it with incredible precision, with atomic clocks so accurate they would only lose a second in hundreds of millions of years. We have built our entire civilization around its steady, relentless march. But what if this feeling, this deep intuition, is wrong? What if time is not what it seems? The more we learn about the universe, the more mysterious time becomes. Our earliest ancestors looked to the heavens. They watched the sun's journey across the sky, a grand and reliable clock. As our societies grew more complex, so did our need for more precise measurements. We built water clocks, created hourglasses, then came the mechanical clock. In the 20th century, we made a monumental leap. We created the atomic clock, using the natural, constant vibrations of atoms. This precision allows for technologies we now take for granted, like the GPS in your phone. Then, in 1905, a young patent clerk in Switzerland named Albert Einstein shattered this picture forever. He introduced his special theory of relativity, and with it, a radical new idea. Time is not absolute. It is relative. Imagine two twins. One stays on Earth, while the other travels in a spaceship at close to the speed of light. When the traveling twin returns, they will be younger than the twin who stayed behind. Astronauts on the International Space Station, orbiting Earth at over 17,000 miles per hour, age a tiny fraction of a second slower than we do on the ground. Einstein was not finished with his revolution. He proposed that the 3 dimensions of space and the 1 dimension of time are woven together into a single 4-dimensional fabric. He called this fabric space-time. Imagine space-time as a vast, flexible rubber sheet. Massive objects like stars and planets create dips or curves in this sheet. These curves are what we feel as gravity. This effect becomes extreme near truly massive objects like black holes. As you approach a black hole, time would slow down dramatically for you relative to an observer far away. At the event horizon, time as we know it would effectively grind to a halt. In our world, cups fall and shatter. They do not spontaneously leap up and put themselves back together. You would know instantly that the film is being played backwards. It is absurd. It is impossible. This one-way street for processes is what physicists call the arrow of time. This arrow is one of the most powerful and intuitive feelings we have about reality. But here is the puzzle. The fundamental laws of physics that govern the atoms of the cup do not have this arrow. A movie of 2 atoms colliding looks just as plausible in reverse. You can think of entropy as a measure of disorder. A tidy room has low entropy, but a messy room has high entropy. There are a vast number of ways for the room to be messy. The universe has a fundamental preference for messiness. This preference is enshrined in the second law of thermodynamics. In any isolated system, the total amount of entropy will always tend to increase over time. A hot cup of coffee will always cool down, spreading its heat energy randomly into the cooler air of the room. The heat will never spontaneously flow back into the cup. This relentless increase in entropy provides a powerful explanation for the arrow of time. The reason time only moves forward is because that is the direction in which disorder increases. The Big Bang, the event that started our universe 13.8 billion years ago, was not just the beginning of space and time. It was the beginning of order. The energy and matter in the very early universe were distributed in an incredibly smooth and uniform way. This was a state of remarkably low entropy. The universe, in a sense, is like a wind-up toy that was wound up at the beginning and is now slowly unwinding. The unwinding process is what we perceive as the flow of time, but this just pushes the mystery one step further back. Why did the universe begin in this special low-entropy state? We do not yet have an answer to that question. One of the most profound implications of Einstein's work is a concept known as the block universe. Imagine all of history laid out like frames on a reel of film. That is the block universe. It is a static, four-dimensional block of space-time containing every event that has ever happened, and every event that ever will happen. Your birth, you reading this very sentence, and every moment of your future are all equally real. In this view, our powerful feeling of time flowing is a profound illusion. Think of it like a spotlight moving along the film reel. The spotlight is your awareness, creating the sensation of a story unfolding moment by moment. Hermann Weyl, a contemporary of Einstein, famously said, "The objective world simply is, it does not happen." If you thought relativity was strange, the quantum world is another level of bizarre entirely. And when we ask what quantum mechanics has to say about time, the mystery only deepens. One of the central equations of quantum cosmology is called the Wheeler-DeWitt equation. The variable for time is completely absent. It is gone. The equation describes a static, timeless universe, a universe of is, not becomes. Some physicists propose that all that exists is a vast collection of nows, all the possible arrangements of everything in the universe. Think of it as an immense landscape of possibilities. Where is the bridge between the timeless, static universe described by physicists and the dynamic, flowing world we experience every day? The bridge might be consciousness itself. Our brains are physical systems. They are complex, entropy-producing machines. The very act of thinking, of forming a memory, is an irreversible thermodynamic process. A memory is a record of a past, lower entropy state. We can only remember the past because that is where the information was created. And creating that memory increased the overall entropy of the universe. This connects the vastness of cosmology with the intimacy of our own minds. We are the universe's way of experiencing its own journey from order to disorder. For thousands of years, philosophers have grappled with the mystery of time. The ancient Greeks had chronos, chronological time, but also kairos, the opportune moment of significance and meaning. Immanuel Kant argued that time is not something that exists out there in the world, but a fundamental structure of our own consciousness. It is like built-in glasses we can never take off. The scientific and philosophical paths seem to converge on a similar conclusion. The time that matters to us might be a story we tell ourselves, a framework we impose on a universe that is, at its deepest level, timeless. The great astronomer Carl Sagan famously said, "We are a way for the cosmos to know itself." Perhaps our experience of time is central to this process. Our minds, by experiencing the universe sequentially, are what turn the static is of the block universe into the dynamic happens of our reality. We introduce a narrative. We create a story with a past, present, and future. The flow of time that we feel might be the very process of the universe becoming aware of itself. Both the timeless reality of physics and our flowing experience of time are valid descriptions of the same reality. One is the objective view of the entire territory. The other is the subjective experience of the journey through it. Our exploration ends where it began, with a sense of wonder. The universe does not easily give up its secrets. The mystery of time is ultimately a mirror. In asking what it is, we are really asking what we are. The fact that a collection of atoms forged in the hearts of long-dead stars can come together on this small blue planet and look back out at the cosmos and ask, "What is time?" is perhaps the most wonderful thing of all. And as long as we continue to look up at the stars and wonder, that story, and our journey to understand it, will never truly end. The clock is always ticking, and the cosmos is always waiting.